Welcome to the first of our Australian iSight Studio webinars for this year. Today I introduce Lance Steele from our mine measurement team, who will be running through some of the underground applications of the iSight Studio Geotechnical module. Lance is new to our team and has plenty of experience underground in Africa, much of which is applicable to our local underground mines. Now, if you have any questions during the session, type them into the question box on the GoToWebinar panel and we'll try to address them at the end of the presentation. Now over to you, Lance.
Thanks, Steve. Hello, everyone. Great to have you here today. My name is Lance Steele, and my background is a geologist by profession. I've been involved with a number of operations in Africa, as Steve said, focusing particularly on open pit and underground geotechnical applications. Today I'm going to be looking at a couple of scans in iSight Studio. I'm going to show how to apply the data captured to a range of geotechnical parameters, which I'll talk about in a moment. So today we're going to be focusing on scans that were captured by our 8200. That's an underground scanner. It's specifically designed for underground environments, in this case to see directly above itself. You place the scanner either on a tripod, as you guys can see on the right hand side image, or alternatively you can place it on a boom and then extend it out into a stope. So typically a normal scan takes about 3 minutes to capture, and one scan will take about 4 million points. Each point that is taken is about 6 millimeter accuracy, so it's at the end of a single scan you've picked up a high level of detail. Users and also surveyors must also note that these scans can easily be used for survey applications on a normal day-to-day basis for underground mining. Now the aim today is to show you guys how the data is obtained inside iSight Studio and how this can be applied to rock mass classification systems. One of the first pros about this system is it reduces your time in underground environments and more time basically allowing users to obtain vast quantities of data that can be applied to any third-party other rock engineering programs. But one of the more important things is it helps to just improve your safety in the underground mining environment. So obviously a great tool for the rock engineers. So just a brief intro into the applications to rock mass classification systems. So basically the next slide includes the critical applications to rock mass classification systems. So some of you will be familiar with these graphs. On the left hand side we've got the geological strength index. If you look at the center of that graph, you'll actually see there's little measurements. So you got 1 centimeter up to 10 up to 100 centimeters. Those are essentially used for the joint spacing, and we'll be looking at that in a bit later, how to obtain that easily. And then you guys can export information from there. And the other option that we'll look is the block volume. So key block volume, so working out the tons of a actual block. We'll then move on to applications also related to Q system, the rock tunneling quality system. So if you look at the bottom of your screen, you'll see there's the Q equals RQD over JN. JN stipulates the joint number, so the number of joint systems in your rock mass. So in this case, we're going to be looking at 1 or 2, which you can apply to your equation. We'll also be looking at the bolt spacing as well as the bolt length application. So it's more of a reconciliation tool in that aspect. Moving over to the rock mass rating, we'll also be looking at the strike, dip, and dip direction. So in this case, we'll be looking at the tunneling, so favorable versus unfavorable dip and dip direction. So you guys can reconcile this against your actual mine design. Again, with regards to the mining rock mass rating, and the rock mass rating itself, the joint spacing as well. And then for the mining rock mass rating, we'll look at the joint set number as well. So those are some of the applications. I'll also talk a bit on the waviness functionality and the joint propagation to help users predict ground conditions going forward, sort of in an advancing environment. And they can also identify the level of spalling rates. So doing analysis of 2 scans comparison or a scan to a surface. So you look at the spalling rates of side walls or hanging walls over time. So with that, I'm going to pop over to a live demonstration of the actual software. So this is typically the eyesight software that we use, and most of you will be familiar with this. So to go straight into it, basically I've got two scans, two underground drive scans. So I'm just going to rotate the data and bring it into view. So there you can see two separate scans. If I really wanted to, I can actually look at view the scan from origin. So I can right click on the actual data and say view scan from origin. If I want to, I can actually also hide the other scan that I don't want to look at, and I can rotate around. So as I rotate the screen, you guys will notice sort of the quality of imagery that is actually being captured here, which is quite nice. All right, but what I'm then going to do is actually go into how to process it for geotechnical functionality. So what I'm going to do now is I'm going to color both scans separately. So I'm going to select them and select Control 2 to give them both a separate color. All right, so there's two separate scans. You can see where they overlap. And my focus is kind of going to be where the scans were taken and also where they overlap. So what I'm going to do is go to the point selection tool, go the freehand selection mode, and just simply select the points that I'm after. All right, and once I've got the points selected, then I will actually crop them out. And the reason to do this is you don't want to be modeling anything else. All the data at the bottom is actually a reflection from water underground. So I'm just going to crop that out. So using the crop tool, it's going to crop all the data that I'm not interested in. If, for example, you've got other areas that you are not interested in, including that, and holding down the shift button, you can just select areas that you're not interested in. Obviously, in this case, underground, the floor environments we are not interested in. So with this data now ready for processing, I just need to select all the points, go to filter, and select minimum separation. And the minimum separation of 0.035 is pretty good. The reason why I want to do that is after this, I'm not going to select apply, but what I can then go and do is go into the complex 3D surface, select 0.250. Now this is kind of like the feature size, so the maximum, the smallest feature size that the software is going to make. Because if there's any data that's missing in between scans, you don't want it to give any false positives. Right? I've actually created one of the surfaces beforehand, so I'm just going to cancel that and close this window, and I've actually got the surface here. If I right click and say view selection. So under the complex 3D surface, two will be created, projected, and original. In this case, we'll be using the original, and you'll actually start seeing now sort of the level of detail that is actually being created. So you'll see some holes. That's where the 0.250 meters comes in. So basically just making sure there's no data that's actually, or surfaces that are actually created. All right, so now I've got a couple of geotechnical discontinuities. What I can do is I'm going to close that window, go to Geotech, and you'll notice that I've got quite a few here. But what I've also done beforehand is I've actually done a couple of them beforehand. So what I'm going to do is just drag and drop those discontinuities into that container, select that, go to Geotech, and steer net, and I'm going to drag and drop that whole container and select the poles and planes tick box. Make sure they're both ticked and say OK. Now straight away on the left hand side of your screen in the container window, you'll see a steering net has been populated. Just right click and say view selection. Now you'll see quite a few planes have actually been created here. So what I can then go and do is just hide the poles, and I can hit the plus button on my keyboard, and that just increases the size of these actual discontinuities poles. So what I can also then go and do is select the number of discontinuities, and you'll see the ones on the left hand side will be grayed out relative to the ones on the right. So from here I can actually see that there's two joint sets. Now this joint set number, so it's either 1, 2, or 3 in most cases. This can actually be applied to the Q system under the RQD over JN, so the joint number. and it can also have applications to the mining rock mass rating option as well. Also, in addition to this, these you can reconcile using the SteerNet and both the tools. If I just tile these, you can see them in relation to a operational, just making sure that your drive is favorable. So if you are looking at the rock mass rating, you can actually see whether the joints are favorable or unfavorable in relation to the direction of your drive. Right, so with that being said, you'll notice that on my screen, I'm just going to go into the actual, or scroll into the close-up of the surface. You'll see that some discontinuities are highlighted green and some are not. This is because it's integrated, so the discontinuities on the right-hand side are integrated with the left, the ones that I've selected. So in this case, I want to do a joint spacing of this, of all of this data. So what I can then go and do, I don't have to do anything on the left-hand side. I just go to Geotech and go to discontinuity spacing. I can select using my middle mouse button, I just click and hold. I can either click from the left-hand screen or the right-hand screen, any of the data. You just drag and drop it straight into the discontinuity spacing folder. Now, with this data, I can either choose to use an orientation line. Let's say you want to do it along the sidewall of a actual underground tunnel. In this case, I'm just going to leave that unticked and just say OK. Now, straight away, the analysis is done quite quickly. So if I just bring that window up a little bit more, you will see that in the report window at the bottom, I'm just waiting for it to render on your guys' screen, but basically what it shows is the statistics of all the discontinuities. So one of the main things you'll be after is obviously the mean, but also pay attention to a maximum and minimum as well as a standard deviation. But in this case, we're looking at about a 4.7 centimeters spacing. So that's quite nice. And then in addition to that, I can actually view these discontinuities in 3D. And what's happened, the way the system works, is it's actually leveled off all these discontinuities to a horizontal plane and actually created what we call measurement lines. So if you collapse that folder, you'll see measurement lines on your screen. So that's quite useful to have at hand. Now, the spacing can actually be used for both the geological strength index, so on the left-hand side of the GSI, as well as also your rock mass rating and your mining rock mass rating, which is quite nice. So with that, I'm just going to move on and look at some key block analysis and some key block volumes. So I'm just going to close that window and close that one as well. So I'm just going to bring in the actual surface as well as some discontinuities that I just identified that have potential as a risk, if you will. So you can see 4 discontinuities in 3D on your screen. If I select the folder that they're in, they'll be highlighted in light green relative to the surface. And those 4, what you can do, you can actually right-click on them and say extend to intersection. So as long as they're all selected, you say extend to intersection, and look what they've all immediately done. They've all extended themselves quite nicely. All right. So from there, you can actually do some analyses on the surfaces. And an alternative option is to right-click and say add points, and add a few more points if you want. But what I've actually done beforehand is I actually right-clicked on there and say add points, and then you adjust it accordingly, and then say select them all and extend to intersection. Makes it a little bit cleaner. So beforehand, I actually prepped those discontinuities in accordance to the surface. So you'll see they're only sort of projecting down a certain level. And then from there, I go to Geotech, discontinuity solid, and I just select those discontinuities. Sorry, not the folder. You actually have to select the discontinuities, drag them into there, and you'll see what it's created as a sort of a halo. But you can also trim that discontinuity solid by actually selecting each one of these points, 1 and 2 and 3, where basically the so if I point that out again, that's 1, 2 and 3. those 3 points, you can add them. So it's basically where the discontinuities are meeting together at the actual surface, and you just say add once it's done. And once you're done, you'll see a plane wave being created, and you just say, okay. Just for the simplification of this webinar, I managed to generate it beforehand. So if I hide that and I just go to the discontinuity solid, so this is the discontinuity solid in the hanging wall. So that's also quite nice. On top of that, I can select it. I can go to query, close solid volume, and I can select a density of 2.8, for example. Just make sure I got the tick box on under close solid volume, and you just say okay. And straight away you can you'll find out that that block potentially weighs about 38.82 tons. It will be reported at the bottom of your screen over there. All right, so one other thing that's also quite useful, you go to Geotech, StairNet, you just drag and drop that StairNet, those discontinuities that I used earlier. There they are in your screen, and you say okay. Once it's done, I'll view the second StairNet, and what you'll see on your actual screen is a couple of planes and where they intersect. So something to note, that where these planes intersect, if for example this is sitting directly over the center of the StairNet, then that block, even if it's 3 planes, you can use 3 planes or 4 planes or more. If that block is sitting directly over the center, for example, it has a higher chance of falling out from gravitational fallout, that wedge. In this case, this block, because it's sitting away from the center, is slightly less risky. But if it does overcome your friction plane and there's any movement, it can potentially fall out. So just a way you can actually analyze if need be. So with the key block volume, this is quite good for the actual volume itself. Can be used for the geological strength index on the right hand side of the graph. So that's quite nice to have it at hand. All right, so I'm just going to close off some of this information and show you guys some rock bolts that I've captured from the scans. So for example, I've got quite a few here on the screen. So these are the rock bolts that are pre-digitized. These have been captured directly off the actual software. The rock bolts have been captured using we go create survey points, and you just digitize, and these have been captured directly off the scan itself. We can go one step further and actually digitize the rock bolts. I'll give you an idea of a couple of them sticking out of the hanging wall. You can see them on your screen. So these, what I can go ahead and do is actually digitize a new one for you guys to show you the process. So what I'm going to do is actually just hide those rock bolts, hide the lines from the screen, and I'm actually going to hide this and bring in the scan that I'm after, and that is scan 2. Just going to wait for it to load and say view scan from origin. All right. Sorry, wrong button. So what I should have actually done is select the perspective box, which is this one over here. And I just put my center of rotation using this button over here around that rock bolt. I'm not too sure if you guys can see that rock bolt in 3D, but it's pretty clear to me because these have actually been captured off the scan. And what I can then go and do is select a new, create a new line, rotate it around the data, select one point, and select another point, and just right click. And you'll see now that a line has actually been generated. So I'll just close that window and hide the scan, because all I'm after now is that line. So what I'll do is keep it on freehand, select the point selection tool. Just make sure that the line, the end of the line has been selected, not both lines. And I go to the translate tool. On the translate tool, the second drop-down option, it's translate data, select 2 points and distance. So what I'm going to do is select the bottom first and then the top. Right, and you'll see an arrow will be selected there. That line is 6 centimeters. So I'm going to take 6 centimeters off. So I'm going to let's assume the rock bolt is 2 meters long. So I'm going to change that distance to 1.94 in the distance, and I select the translate data, and I just say translate a copy and translate forward. And all I have to do is just close that window. And straight away you'll see that rock bolt will be there, and that's now into the hanging wall. Users must just be aware that sometimes, and to be honest, quite often, sometimes the rock bolts can be misaligned. You can just go to the freehand tool up here to adjust that rock bolt accordingly. So if I bring in the rock bolt lines that I had earlier and bring in the discontinuity solid, you can actually see sort of the premise of how well those rock bolts are going to potentially hold that block. I can then go ahead and actually select that block and go Control G and just change the translucency of it to view the scan, the actual rock bolts in 3D. Right, so again, with regards to the Q system, that rock bolt analysis, guys can do some reconciliation of the rock bolt distribution and extrapolation. Guys can also do this for rock anchors as well. And according to your mine legislation, you can also then go ahead and actually check your joint spacing either in advance or going sideways. So in addition to that, we also have the waviness tool. I'm not going to talk too much. It's under geotechnical waviness, but users that can know that it's there, you can calculate the level of undulation for the mining rock mass rating. In this case, I'm not going to talk too much about it because it's underground typically has a higher stress, shear stress component, which typically shears undulated material. So I'm just going to move on to my next feature in this webinar, which is projection of surfaces in an underground environment. So for example, if I bring back my surface, go to discontinuities, and bring in just a couple just to show you guys. So there are a couple. Let's say, for example, that my advancing is going to the top of my screen, and I want to see, how much that a single plane, which you guys will see on your screen now, the light green one that's been highlighted. All I need to do is right-click and say on the actual discontinuity, and say Add Points. Now this is quite nice if I want to know sort of where that joint is actually going to be in 3D. So sort of a grey ghost halo will come up, and I'm just going to wait for that to render. There we go. And all I need to do is select anywhere. It can be anywhere, and just say okay. And what I can do is select the next one, Add Points. There you go. And that's quite nice. A new feature that's coming out in Studio 8 is being able to select the block, an area, a specified area, and extend all your discontinuities to that, which is quite nice. So this is quite nice just for a reconciliation and checking the advancement of your ground conditions going forward. Right, so with that being said, I've got one more thing to show you guys today. So I'm going to show you guys a board and pillar mine, so I'm just going to bring in a single scan. What I'm going to show you here is the spalling rate over time. So how to analyze effectively if it's your normal board and pillar mines, you've got your pillars, you can do some analysis on those as well as your rib pillars, as well as any other sidewall components where you've got. This is quite nice to do some reconciliation in areas where you identify that there's been some high pressures either on the sigma 1 or sigma 3 component. So what I'm going to do with this actual scan, I'm actually going to show you guys a quick process. So we use the color by distance tool, but beforehand users just need to make sure that they go model scan triangulation of both their scans, or at least a scan and a surface, and go to color distance from objects. And all they need to do is put the base in here, so either the surface or the original scan, and make sure that they've done a scan triangulation and drag and drop the base into here, and then just select the other one, for example, this one, and then drag and drop the base into here, and then you say, okay, but I've already done that just to speed up this process. It takes a couple of minutes, but once you get it, I'm going to show you guys what it looks like now. So you'll notice that a scan triangulation can be quite a bit messy. So one of the best ways to view it is you actually select this little set camera viewpoint. So you select it once, you just select your scan that you're after, right click and say origin of scan, and you just select the surface. And straight away you've got your view scan from origin but inside an actual surface. And you'll notice now that you can actually see the spalling rate. Now these two scans are taken over a separate time, over 2 separate months. Now if there hasn't been too much significant change, you can actually just take a free scan and just model it up to the previous one, which I did in this case. So you can see, certain things have been added to this area, such as sort of ventilation pipes and whatever. But the more important part here is actually seeing what's in your view here. And what's quite nice as well is a legend can also be created. So you can actually view sort of what threshold means what. So you can see what material has fallen out of the pillars or the sidewalls. And again, if there's been any significant stresses, you'll notice some form of bulging or movement. And you can, as I rotate the data, you can actually go ahead and view some of the data in the actual hanging wall, for example. So there's just an image of the material in the hanging wall. So useful applications for this sort of system, like I said, spalling rates over time for pillars and rib pillars, and also stopes if you've got access to them and you just want to see how they're progressing over time, you can do that. And then also some valuable applications is seeing the drill and blast effects in an open stope. How well is the ring design, drill holes being drilled, or are they, when they initiate, when they fire, or is the blast actually doing more damage than good, causing potential like dilution or structural changes in the actual sidewall that may be of a concern at a later date. So these are some of the applications that the system can have. With that being said, I'm all complete. So over to you, Steve.
Hey, thanks, Lance, for the informative presentation. You've generated some interest from our viewers, and I've got a couple of questions for you. So firstly, can you export the discontinuity spacing data that's been captured in the scan, and if so, what formats do you support?
Oh, that's a great question. Hey, Steve, the short answer is yes, we can. So what I can do, I'll just show you guys a quick snippet of that. So what you can do, you can actually go to Geotechnical, select for example, your discontinuity spacing. You can either select one or the other. In this case, I'm going to select all, go File, Export, and you can have a choice of multiple options. So in this case, I would select the point text file CSV. But if I, for example, selected just the discontinuities, you'll see the discontinuities CSV file. Or if you guys have Vulkan, you can export it out, particularly just for a Vulkan database. And you just say OK, and it will go straight out, and you can specify the discontinuity type.
Okay, next question. Some of those images look pretty high resolution. How much geological mapping can you do with that scan data?
The scans themselves are actually quite high resolution. You've seen some of the data. With the scans, you can actually see quite a bit of detail because of the reflectivity intensity. But something that's also quite useful, I'm going to show you guys a quick scan that's had an image draped over it. So you'll see, and it's quite high resolution, so there's a rock bolt that's actually hosting. And if I want to see that in 3D, you can actually see the mesh with the image draped over. So it's just a scan triangulation at the advance of a tunnel, and you can see pretty much all the drill and blast lines, and sort of which blocks are going to initiate first, etc. So with that sort of image, it's quite high quality and quite useful. So in addition to that, we will be having our there's the ZR3 laser scanner, underground scanner, which will be designed particularly for underground, and that will have a built-in camera, and that is soon to be released in the next couple of months.
Thanks, Lance. The underground pillar you showed towards the end, you had deformation between two scans. Can you monitor it over time just to track the history?
Yeah, absolutely. So what we can do is we've got a system called Sentry. It's the software is secondary to iSight Studio, which I'm using here, but it's based around the same scanner. So the scanner can be set up permanently or for long term, and set up into a crushing area or working area, just where areas are of concern, and any movement thresholds that are alarmed, users can actually set alarms to send an email through to the guys, and we can also do email to SMS. So that's also quite useful. Users can actually go and grab the scanner anytime, go do some geotechnical mapping and bring the scanner and let it carry on doing some monitoring for you.
Okay, and the final question we have here is, can you colour the scan with a heat map of the discontinuity shown in the key block failure window that you had on the StereoNet?
Yeah, absolutely. So, for example, if I bring this surface into the view window, what I can then go and do is go to Geotechnical and color dip and strike, and as long as I've got it selected, I can say specify dip direction under the spectrum, and I can limit the dip range and dip bearing, but we've also got a potential heat map coming up in Studio 8 or 9 that will also assist users in looking for some rescue planes as well.
Well, thanks, Lance. That's all the questions for now. Thanks again for the overview of some of the underground applications of the iSight Studio Geotech module. Customers with current software maintenance can download the latest iSight Studio version from users.maptek.com. If you don't have a registration or a login, just go to the register button, and if you're on current maintenance, Maptek will send one out to you. Now, once you do log in there, you'll see that the latest version of iSight Studio is 7.0.2. That's available for customers with maintenance dates up to the 26th of June this year. Now, once you've downloaded that, if you have any questions about installation or support or use of iSight products, contact your local Maptek office with the details as on the slide there. Now, if you'd like to see this webinar again, or if you had colleagues who didn't get a chance to join us today, you'll be able to view this webinar on maptek.com in coming days. Now, once you're there, you can have a look at future webinars that we've got programmed, and also our history of previous webinars. If you do have a webinar topic that you see that you would like that is not currently advertised, contact your local Maptek office, and we'll consider running one of those in the near future. So then, thanks again, Lance, and thank you again for our viewers. Look forward to catching you on the next webinar, and bye for now.